Hi all, welcome to my YouTube channel. Today I'm come up with a new series in the field of AI called reinforcement learning. I think most of the people heard about reinforcement learning, but very least people are using these type of algorithms in the current industry. But there are a lot of research and some of the current solutions, especially built by ChatGPT or a DeepSeek, especially uh, in the field of AI, they are using reinforcement learning techniques. But when it comes to the reinforcement learning techniques, these algorithms are a little bit quite different when it comes to the compared with the traditional algorithms like machine learning or any deep learning algorithms. So in this series, I would like to come up with each video with the intention of try to make the audience understand the core concepts of reinforcement learning and followed by how we can correlate with the real world examples and try to implement those algorithms and solve some of the problems in the real world use cases as well using RL technique or reinforcement learning technique. So in this series, so I would like to come up with more videos, especially in the field of reinforcement learning, and try to solve those problems mathematically and try to come up with coding activity as well so that we can easily understand each core concept behind the reinforcement learning. So in this today video, I would like to share some of the key insights of RL techniques and some of the uh, application where we can use reinforcement learning to solve the problems and some of the differentiation between the difference between the current machine learning algorithms and deep learning algorithms, how we can compare those techniques with respect to the reinforcement learning. So let us start with our first slide. What is reinforcement learning? So the name itself tells reinforcing. That means for anything we try to make the forcefully adapt for the environment or adapt for something by learning the some of the things for the given states. It's quite complicated if I use the traditional words or a method to explain the reinforcement learning. That's not an idea to make this video as an academic. Instead, that make the video as an easy to for the any audience to capture those concepts easily. So reinforcement learning is a kind of machine learning paradigm where the agent will try to behave with respect to the environment by doing some of the action and receiving some of the rewards or some of the penalty for those action. That means if you take any example, so let us take a kid try to uh, walk at the earliest stage of during you can consider as in 1 year, 1.5 year or 2 year. The kid try to stand and try to put one step ahead to get some toys or some ball. So in each step, kid might fall down. Sometimes kid might put one step to take a particular toy or a ball and is able to success. For example, in this case, if you consider kid brain is trying to learn something, how to walk, how to reach from point A to point B to take a particular a ball or a toy, that's an goal for that particular kid at this point of time. So here the kid is trying to interact with the environment its surrounding, and sometimes when it fell down, it's a penalty for the kid. The kid might get hurt, it might get cry as well, but when the kid get hurt or he's feel the pain when his kid, that's a penalty for try to take the particular toy. It might be the path might be different. A kid might not holding any support. That's the reason could be it fell down. At the second time, the kid might try to hold some nearby equipment or nearby support and try to walk for try to put one step ahead to take a particular toy. In that case, the kid might get success. If it is get success, for example, his mother might give a claps, so the kid was able to collect something. A kid able to get one step towards the toy. So in that case, the reward was given by his mother in the form of claps. So the kid brain able to understand, if I hold this chair or if I hold these supporting things, I can able to put one step ahead. Like that, in the next time, for the next step, the kid might put another step with the support of some chair or something by holding. So the kid understand that if I do like this, I can get more claps. What do you mean by claps here? It's a reward given by his mother. Whenever the kid fell down, he tried to understand, I am not hold this any chair or something. So that's the reason why I fell down. So I try to get reduce his penalty over the period of time. So the idea is the kid is trying to accumulate the maximum cumulative reward over the time to achieve his goal. Here the goal is try to get the toy which is far away from the kid. So in this case, there is no any a label data associated with the given input case, but the kid is capable of learning by itself and try to achieve his goal. So for example, if you consider its best example in the current scenarios could be autonomous car, where it takes the real-time decision whether to take left, whether to take right, or to accelerate in order to increase the speed. And sometimes if you take some of the robotics, where we can able to see the robots are controlled and able to walk in the complicated space in the where the human can able to walk as well, but the robots are quite difficult for them because it needs whether the path is correct or not. So in this case, the robot capable of learning by itself and try to walk in such a unfashioned road. So as they say, if you see, let us for example, if you consider another examples, sometimes in nowadays, if you see in the Google ads, most of the times we are receiving the Google ads whenever we are browsing something. So that's also type of reinforcement learning. At the back end, they are learning running some of the reinforcement learning approaches to send for you a particular ad, whether it can be useful for you or it's whether you can click an ad, click on those ad. So that creates a revenue for the Google. So those are some of the key elements of area where the reinforcement learning is currently utilizing. So if you get into the key concepts of reinforcement learning, what we call as an agent and environment and some actions, some state and reward. So agent is nothing but a learner, a kind of decision making, what we call as the previous example, what I explained, that kid is an agent here. And at each step, the agent observes the current state and take an action. So in terms of kid is try to capture the current environment and take an action based on the current state. And sometimes it might get a reward, and sometimes It's a punishment that causes the from the previous state or a decision which is taken from the kid. So the surrounding, the world, the agent interacts with the environment. So when it comes to the action, what agent can do, whether agent can do take an action based on the current state and the previous state as well. And the state represents the current situation where the kid is standing. At the same time, if you consider the reward perspective, of course, which I already gave an example of, whether what you are getting when you do an action, whether you're getting the positive reward or a punishment, like that. So if you get a positive reward, that means that you can learn something which is favorable to the target goal of an agent or a kid. So when it comes to the reinforcement learning, it's not a kind of supervised machine learning algorithms. There is no correct answer provided by or given to the reinforcement learning. The agent will try to learn through his experience, explore the different actions. That's the main key concept. In the machine learning field, where we can try to see there are two types of machine learning, especially supervised and unsupervised, where we have a data, where we does not have a data. So those type of approaches is completely different when it compared to the reinforcement learning. So some of the as I mentioned, the key concepts like agent, environment, state, action, reward, policy are the some of the surrounding key concepts of reinforcement learning. So at the same time, we have another key concept called policy. So what do you mean by policy in this case? So I gave an example. Instead of giving an example, the policy is nothing but a strategy that defines the agent how it's supposed to be behave, mapping from one state to the action. That means if you take an example, the kid try to understand how to stand, how to walk by holding a supporting material or a chair, and try to walk and try to reach his destination to do or collect the toy. In this case, so these are the steps or the policy that the kid learn from his experience with reward points which is shared from the which is given from his mother or surrounding person, and punishment also during the his learning phase of his walking. So if you consider, these are the policy is nothing but a strategy that defined by kids itself to how to behave itself, to map from to reach its destination, to maximize its reward points. So there are two types of techniques. For example, exploration and exploitation. In exploration, we try new action to discover the new knowledge. For example, if you consider, we're trying out a new action to discover their new potential reward. For example, if kid, instead of holding the support, if the kid tried to remove its supports and try to walk by itself, it's a new discovery of reaching the destination without the support. If it is get fell down, that's a punishment for the kid. If it is not fell down, it's able to put 2 steps ahead, that's a reward point for the kid. So in this case, the kid is trying to find a new way and a shortest path to reach his destination. That is what we call an exploration. Exploitation means leveraging the known action that gives high reward. kid learn already something and try to utilize the same technique or a strategy of policy to reach its destination. So in both the case, if the kid want to learn new technique, it might need some extra time. So it's a slow progress. And if it is exploitation, risk of finding the new case, for example, to especially in the trade-off, especially if it is too exploration, it is going to be slow progress. Too much exploitation, risk of not able to reach a particular destination. So if I give a real world example, imagine you are in the new city and if you want to find the best restaurant for your dinner, you could revisit a known good restaurants. That is what we call as an exploitation. Or you try something unknown that might be better. Exploration. So in exploration phase, you try to figure out some of the new restaurant but roaming around the city, but it might take some time. You might end up with your goal, finding the new best restaurant, but sometimes you may not end up with a good restaurant, or you might not find any restaurant at all. In this case, it is too risk, especially in the exploitation phase. There are different algorithms. I will come up with those algorithms in the coming videos, especially epsilon greedy and upper confidence bound. So manage this type of balance. So the idea is whether to choose exploration or exploitation. It depends upon what algorithm we are going to use. So as we already know that in the machine learning field, we have supervised and unsupervised machine learning algorithms. So in supervised machine learning algorithms, we have an input label data, of course. The output could be predictions, whether it's a classification or it could be a regression problem. So I'm not getting into the detail about supervised or machine learning techniques. Instead, I try to distinguish between what is supervised and unsupervised and reinforcement learning. So in the field of in the type of supervised learning, we try to learn mapping the function that maps the given input into the output. So of course we have a label data, the given input, and try to map those input data into the output one with the help of some type of algorithms or whatever it is. We have a function that maps those two things. That is what we call as supervised. But in unsupervised, we does not have a label data at all. But we try to discover the structure in the data itself. How? With the help of clustering. So clustering will captures the hidden pattern behind the data and try to group those input data into different groups, what we call as a cluster. So these are the main idea behind any machine learning or a deep learning algorithms. How we utilize any given problem statement will be fall under supervised machine learning algorithms or unsupervised machine learning algorithms. So based on these things, we try to address the any ML given problem statement in these two areas. But in the reinforcement learning algorithms, we are not at all dealing with any given input data. Instead, we are trying to interact the input itself. It's an interaction between the state, actions and reward with the surrounding. And what is an output? The output is the policy. a sequence of action what we learn by achieving the cumulative best reward, and we try to maximize the cumulative reward. That's our goal, especially in the reinforcement learning. So once again, I'm repeating the reinforcement learning, what we are doing, the input itself interactions with our agent. Agent is going to interactions with the surrounding and the current state, and the agent is going to give an action, and agent is going to give an received and reward. So those are the input to the words, input to the agent, sorry, and the output is going to be policy. It's a kind of sequence of actions. And what is the aim during to get this policy? The aim is, or a goal is, they try to maximize the cumulative reward by trial and error techniques. So for example, let us give an example like supervised machine learning algorithms. It could be a spam detection with labeled emails. It's one of the best example for supervised learning. For the unsupervised learning, customer segmentations using purchase data, or the customer segmentations based on the credit card or the transaction in the banking section, or in other words, clustering the users based on the purchase in the e-commerce website. So those are unsupervised machine learning algorithms. For example, when it comes to the reinforcement learning, we are training an agent to play chess by trial and error techniques. So these are some of the best examples of the reinforcement learning. And also I can give you another example of reinforcement learning where in the field of IT or in the field of finance, where the agent or a reinforcement agent itself decide what stocks need to be buy and when need to be exit or when need to be sell those stocks in the real-time manner. So in this case, instead of doing all those work from the human, our agent or a reinforcement agent is going to be taken actions which is already learned from the previous experience by trial and error method, and the agent is capable of now handling in the real-time case and capable of selling the stocks and buying the stocks at a good price level and try to maximize his portfolio. So these are some of the best examples of reinforcement learning, and I will give you more details on some of the area where reinforcement learning currently is exploring and utilizing to achieve the business goal, especially in the field of recommendations. For example, if you want to recommend something to the user, for example, let us take in the Instagram itself. Whenever we watch a particular reel, at the back end, there could be a possibility a small reinforcement learning algorithm is running that captures your current watch and try to give a recommendation in the next coming reel based on your activity. The idea is the recommendation it could be try to give an ad. You might click on those ad, so that once you click on those ad, you might end up with subscribing or paying something for those product or a service given by SaaS product. In such cases, so the reinforcement learning agent is try to make his reward making you to click on a particular ad. That's a target in the recommendation system. As I already mentioned, where we can see that best example in the trading strategy, where the agent can be capable of learning the new skill or a new way of buying the stocks or ticker in the field of finance. And also we can see there are some of the game players like AlphaGo and Dota AI, where the agent itself play and achieve these good results when it comes to the human players as well. When it comes to the robotic section, where the robots is capable of playing a football or walking in the forest by navigating in the uh, terrain. In such cases, in the robot having an agent that's capable of understanding its surrounding and try to take an action based upon the reward and punishment which was learned from his previous experience. So those are some of the application currently used used by the reinforcement learning. So the main applications currently, if you see in the nowadays, where our ChatGPT, which was trained on supervised machine learning algorithms, but the DeepSeek was developed from Chinese, was trained those language model using reinforcement learning. So it's a way how we are going to address the problem statement. It's not about what algorithm we supposed to use, what algorithms not be fit into that particular problem statement. It's all about how we are going to address the same problem in a different approach, but each approach might have its own trade-off. Some might be very good at high accuracy, but some might be at average at accuracy. But the idea is both the target in the business use case to achieve the better, the best uh, reason or a best metrics with low training time at low cost. That's an idea. So this is all about today's session. In the next coming days, I'm going to come up with the next reinforcement chapter or a reinforcement series to understand much more about techniques and the algorithms, so that in the coming days we are going to learn a better way how to solve the industrial problem using reinforcement technique. Thank you. Bye.